Welcome to Beyond CUDA. I'm your host, Jeff Tatarchuk, co-founder of TensorWave, the AMD GPU cloud. Today on our show, we have Waleed Atallah, the co-founder and CEO of Mako, a company that is automating kernel generation. Prior to founding Mako, he worked at Untitled AI as well as Intel, where he focused on AI acceleration, hardware, and software. At Mako, Waleed leads efforts to optimize GPU kernel performance across various hardware platforms, aiming to enhance AI model deployment efficiency. Waleed, good to have you on the show, man. Good to see you.
It's a pleasure to be here.
Awesome. Hey, man, let's jump right in. I want to start at the beginning. I want to start with, how did you get into this? What sparked your initial interest in hardware acceleration?
I started my career in semiconductors, basically at Intel. This was, 2016, 2017. It was pretty clear, AI was going to be something big. And so I decided to try to weasel my way into that group as much as possible. And really, there we were doing a lot of, at the time it was FPGAs for deep learning acceleration. And the NVIDIA GPUs were starting to get better and better every year. And I saw the writings on the wall, right? So I ended up leaving Intel to go to a company that was building chips dedicated for AI acceleration. That was Untethered AI. And so we were at Untethered for a while, and then I started to notice kind of the same problems that Intel was facing, or the same ones that Untethered had, which was mainly that writing GPU kernels or chip kernels for any sort of AI workload was a huge bottleneck. There just weren't a lot of kernel engineers, and the good ones are really hard to hire.
Hmm.
So I came up with a couple ideas to try to automate this process. We gave a couple pitches to the team there. They ended up not working out at Intel there, but I thought it was too big of an opportunity. So I left. I joined up with Dr. Mohammed Abdel Fattah, who would become my co-founder, and Łukasz Dadziak, and we started Mako. And here we are. Our goal is to completely automate the generation, the writing, the optimization, the deployment of GPU kernels. And big, tall task, lots of technical risk, but a lot of fun along the way too.
Yeah, no small task at all. Kernels, dive into that a bit more. Tell us why kernels are important. Tell us why kernels are the bottleneck, and why is it so hard to find people who are good at writing kernels?
Yeah, so the GPU kernel, or a compute kernel in general, is basically how you map an algorithm to the hardware. And so, why is this so hard? Because you're not just writing software anymore. You're explicitly mapping different math operations to existing hardware resources. So you need a little bit of software understanding, a little bit of hardware understanding. Or actually, better yet, you need a lot of software and a lot of hardware understanding. And so somebody who has experience across both of those is pretty rare. If I had to guess, honestly, it's probably one good GPU kernel engineer per 100,000 software developers. It's probably around that ratio. Tough part is that once you find a good one, they're already getting paid $500,000 plus at OpenAI, Google, Amazon, you name it. So being able to map algorithms to hardware effectively is incredibly difficult. NVIDIA saw this. They started CUDA, in 2006?
Mm-hmm.
And so how does NVIDIA solve it? They have a massive team. Probably most of the kernel engineers actually work at NVIDIA. And they write all these CUDA libraries, cuBLAS, cuDNN, all of that. And they give library access to their users. So they don't have to worry about writing the kernels. And you can just use NVIDIA. And that's worked out really well for them, right? Well, the problem is CUDA libraries only run on NVIDIA. And, like it normally is, people don't want a kingmaker, right? Where NVIDIA gets to choose who gets AI and who has to wait. People want choice. They want diversity. There's been a lot of progress with AMD on their CUDA equivalent. There's been progress with a whole bunch of other companies that have basically been working to open up this ecosystem, make it easier to write kernels, come up with new ways. But basically, I think there's a long road ahead. And at the end of the day, this rare skill set, it's just hard to find. It's hard to train for. So the singular goal at Mako is to completely automate this process.
Can you dive into that a bit more? How does your approach at Mako differ from the traditional methods?
Yeah, so we kind of the traditional methods. There's three ways to get a kernel, basically. Number one, use the vendor-provided libraries, which somebody had written by hand. In vendor-provided libraries, I include traditional compilers, which use defined heuristics to generate kernels, which this is good. It's less flexible because usually they have a set amount of libraries, so they've already decided what they're going to write the kernel for. If you're doing anything weird or if you're trying to extract max performance, you might not get the best performance out of those, especially for the traditional compilers, although it still does a pretty good job.
Mm-hmm.
And some libraries get really nice performance for very common, like shapes and algorithms. So that's one, vendor provided. Two is expert written. You find someone to write the perfect kernel for your use case, for your hardware, for your data patterns, all of that. So that's the second one. The third way, which is, as you imagine, of growing interest, is using LLM-based code generators.
Mm-hmm.
Really generate kernels from scratch. You ask ChatGPT to write you a kernel for something, it might get you something that works, but honestly, it's probably not going to be good.
Right.
And the time is probably not even going to be correct. Like it could use something that compiles maybe, but it probably won't even work. So what we've been focused on is making this end-to-end automated LLM-based code generation work, and then integrating that into a traditional compiler flow. So where a traditional compiler can use heuristics basically and pattern matching to generate kernels, we also want to give that traditional compiler like a superpower where it can actually use LLM calls to generate and optimize kernels as well.
Interesting. Are you training your own LLM, or are you just fine-tuning an LLM, or?
Yeah, we're not doing any pre-training. We
Yeah.
didn't raise the $200 million round needed to do that.
Yet.
Oh, but we're fine-tuning models. Yeah. Hit the OpenAI API, try the GPT-4o fine-tune. Obviously, Quen, really cool, DeepSeek, Llama models. Really, one of the big challenges, the reason why these models don't do so well at writing kernels is data scarcity. So there's a huge focus on building the data pipelines to get that massive data set of annotated, compiled, functionally correct kernels. And then we use that, we fine-tune our models using all the latest reinforcement learning and SFT and all that fun stuff. And we are getting models that perform significantly better than anything that's out there just off the shelf. And you expect that, right? Like fine-tuning for a specific task gets you better performance of that specific task. But it's not just the model, right? So really important is the data pipeline to get the data, fine-tune to get a proper model, and then the kind of, I call it agentic. That's what I'd say if it was a pitch deck. So scaffolding, the infrastructure, the agent to let it iterate on a kernel and actually generate something that compiles, is functionally correct, and is performant.
Yeah, that makes sense. Yeah, because in the folks that I've already spoken with, they're saying that this whole CUDA moat is like a multi-billion-dollar moat that has been created with the thousands and thousands of developers that have already written these CUDAs and developed these libraries. In order for anybody else to catch up, it would take a significant amount of resources and time to be able to do it. And yet now with AI, it seems like we can help accelerate this process. What are the things that you are currently the most optimistic about as you guys have been digging into this and working on the kernel generation side of things?
Yeah, so the LLMs for code generation have honestly been moving along, and our progress has been a lot faster than I thought it would be. Like we were originally planning on launching something towards the end of the year. Now it's looking like it's going to be this summer. So the progress is just really quick. But I guess I'm surprised a little, but not surprised. The reason why I'm not surprised is because I've been surprised so many times. 2022, right? Like every time something new comes out, I'm like, oh, whoa, I didn't expect that kind of capability. Then the coding models, like they were okay at first, right? But it just got so much better. And look, there's still a ways to go. Like Claude or whatever else is generating like perfectly efficient in a small line of code or any of that kind of stuff. But it works surprisingly better than I would have guessed. It worked a year ago. And I totally expect that with effort, that this trend is going to continue. Not forever, but with the right amount of expertise and the right amount of scaffolding and infrastructure, LLMs, even as they are today, can probably do a pretty good job writing these kind of kernels. So by 2030, come on.
Yeah.
I think we're going to see most kernels written by LLMs by 2030.
Interesting. And do you think like having your own pre-trained model would help move that along? Or you were mentioning that there might not be to do a pre-trained model that would be sufficient enough?
Look, so we're looking at doing a lot. Like, there's obviously a couple different areas you can scale. Three, and you can scale pre-training, you can scale post-training, then you can scale inference time compute. Just given like the resources we have, like we're starting with scaling post-training and inference time compute. We're even doing some continued pre-training too. So there are like different knobs that you can turn to get more out of this. Are we going to need our own pre-trained model? Honestly, Jay's kind of out on that for now. I think Claude 4 or 5 or O7 or GPT-12, whatever it is probably going to be an amazing base model. And I think more important than getting the model perfectly right is building the infrastructure around the model, building the product around it. Like having something that not just generates a kernel, but having the whole end-to-end pipeline. We don't want to just have an LLM that spits out a kernel. We want the LLM that spits out a kernel, the compiler that's able to stitch that all together into a graph and executable, and the full pipeline to get that into VLLM or SGLang immediately. So I think this whole end-to-end pipeline, which goes beyond just having the LLM that spits out a kernel, is going to be really important. It's going to be a big differentiator and making a cool product that actually works.
Yeah, that makes sense. And yeah, just building on top of
We
the
want
base
to
models.
be able to plug in like Claude 4 or 5
Yeah,
or whatever.
just make it work. Exactly.
Yeah.
Now, who are the
And
types
by the
of...
way, my chief science officer and CTO are going to dislike that statement. I think they might
They're like,
disagree.
no, give me the big cluster now.
So
Yeah, of course. A lot of these researchers would like to have their own 8,000 GPU cluster to themselves to be able to to do their own biddings. But it seems like you can get most of the way there with what's currently available, which makes a lot of sense.
yeah.
Okay, so now I remember when we first started talking, you were doing a lot of stuff on the inference side. Are you still doing kind of a bit of both, or what's your current?
Yeah. So basically the way I see it, like when we were first talking, we were looking at doing like VLM optimization, and we actually have that ready to go and people are using it and we're getting good feedback on it. The way I see it is like you can only get so much like performance improvement and usage improvement by focusing on optimizing the inference engine, by adding kernels into the mix, by selecting the right kernels, generating the right kernels, writing new kernels, optimizing kernels, and then plugging those kernels into the inference engine. This really blows the top off and gives you a lot more opportunity. So I see them, it's just two parts of the same pipeline. The pipeline I just discussed, from going from write a kernel, pick an inference engine, optimize that, deploy. I think it's one big pipeline. Like you're going to have to touch all of that if you really want to maximize performance. And
That makes sense. And so the types of customers you guys work with, can you share a story of, or an example of a customer that came to you, you're able to offer your service and the results you were able to get?
yeah, right now, like the LLM kernel generation is definitely still in an early like experimental phase, but we literally were meeting with a large unnamed hyperscaler yesterday. They were here in the offices with us. And we're kind of going over what they want to see in terms of the product, how they want to use it, that kind of stuff. So I think for the kernel generation, the types of customers there are people who already have kernel engineers and want to force multiply the team that they have. People with different types of hardware who want to be able to write that new kernel for whether it's like AMD, Trainium, TPU, you name it, whichever it is. So that's one type. The second type is on the inference engine optimization. It's really just about maxing out performance, right? So we can like easily get like 10 to 30% performance improvement with some like relatively simple optimization patterns that we run. And so we're getting some really nice feedback for that one. Just because it's like easy to use and it's completely automated. The whole point of this company is we have a bunch of kernel engineers, compiler guys. Like we've been manually optimizing like AI deployments for our whole careers, like probably 7, 10, 15, I don't know how many years it is. And we want to take all that expertise and make it automatic. So it's basically about maximizing the performance you can get on a given GPU. There are techniques that a performance engineer can do, or you can flip the switch, push the big red button when our software goes off and does it automatically for you.
That makes sense. Where do you see the biggest risks ahead? What are the current limitations and risks that you're currently facing?
Well, I mean, like there's like the perpetual oh, OpenAI's next model does everything for you. So that's one, which is why like I'm not super crazy about having our own best model. If there's a better model out there, like we want to use that. We'll be happy to like fund open source projects. Like they've been talking to a few people who are looking to train kernel generation models, and we'd be more than happy to like have something completely open source. I don't think the models are secret sauce. But what's another risk? I guess if kernel generation somehow gets solved with like more traditional tools, which I don't think is possible, but if Torch Inductor became so good that we just couldn't get any more performance or barely get any more performance on top of that. I think the main thing is that like I think that we're gonna continuously need more kernels and we need more kernel engineers. I think that comes from three things. Number one, new algorithms. Like people want to try, at least in the research community, non-transformer based algorithms. We talk to foundation model companies that would tell us like, look, if we can throw this PyTorch at your agent, then a week later it spits out a kernel that we can use in training and inference. Love it. So one side, new algorithms typically need new kernels. So if you unlock that, you open the door towards this whole exploratory research area. A second thing is new hardware. Look, even if you go from H100 to B100, like you need new kernels to leverage that. If you go from MI300 to 350, 400, you need new kernels to leverage, that hardware the best. And that's going to be something that always changes. And usually it probably takes like months, right, for a human to do that. It'd be ideal if we could do that automatically. And the fourth thing is that there's still performance to be had with new kernels. Like DeepSeek in January innovated again on top of attention. And with their new kernel set, people were shocked at how efficient it was. So I think that, there's like risk. It's definitely like a technically challenging thing to do. There's a lot of different ways to do it. I just have incredibly high conviction that, somebody is going to make a really nice AI system that will write the kernels for you and integrate it into your pipeline automatically. Whoever figures that out, I think is going to be a very rich man. And then we're just hoping it's going to be us. There's a ton of really smart people working on this from a lot of different angles.
Yeah.
There's no guarantees for anybody.
Yeah. Well, it definitely seems like the pie is pretty big and it's a huge problem that needs to be solved. What do you see as all of the things that need to be done? You have the lane that you guys are currently working in and the things that you're focused on with kernel generation, kernel optimization. Now, there's clearly things you can't work on that also need to be
Yeah.
fixed or optimized. What are some of those things that you wish would be fixed? If you can wave a magic wand over here, while you guys are focused on this, you can wave a magic wand over here and it could be fixed that people should be paying attention to and spend time optimizing.
Dude, there's like probably 1,000 different things that I wish we could be doing, right?
Which would you prioritize?
Like what I've been talking about is like doing compute kernels, but communication libraries are, come on, just as important. If not, like for training, probably more important. And now for inference, we're starting to see like 2024, inference was probably done within a server, 8 GPUs, right? 2025, no, we're starting to look at multi-node
Yep.
instance setup, like pre-fill and decode across these like massive transformer models. So I think that's going to be like one big challenge is the focus on communications, which is something that we're not completely locked in on right now. Maybe eventually one day, but that's far down the road. Another side is there are some things that I don't think should be owned by a company. Like I actually like really support inference engines like VLLM and SGLang. I love the idea of an open standard for how we deploy like kind of some core pieces of AI infrastructure. I think there are some places where it makes sense to have like proprietary software, some ways to tools that can help you build for specific use cases or specific like data patterns or something like that. But there are some pieces that I think really should be community driven. And that include like, it's like, like Linux, right? Good idea. Talk about the gold standard for open source software.
Exactly.
And so I think there's a lot of components like that. Like it's like a VLLM. I want to see a VLLM for training like DeepSpeed, right? Something that makes it like super simple to do this kind of distributed training. The work that PyTorch does, the entire PyTorch project is like the backbone of open source AI. And then even like PyTorch competitors like JAX, XLA, that kind of stuff. There's a lot of things that like we don't and shouldn't be focused on. And I think a lot of those Like, it pretty much comes back to the open ecosystem that kind of enables more companies and more researchers to participate, which is like speaks to the importance of having more than just one specific vendor or one specific software framework that dominates the entire industry.
Mm. Yeah, that's big. What does Mako need right now? Is it more developers? Is it more customers? Is it more resources? What do you guys need right now that would,
Our
if you can make
investors would always say more customers, right? We need more GPUs, man. If I could run more experiments and more like fine tuning and like RL runs, like that would be probably a way for us to move a little bit faster. I'm really happy with the team size right now. So I think we're in a good position. Like we have what we need to keep making progress. I think like the gasoline on the fire is basically more, which is probably what every AI company says, but more compute, right?
That's
To
right.
run experiments and that. It's the bitter lesson, man, right? The bitter lesson always wins. So whoever you can multiply like the amount of exploratory paths that you take, you're more likely to find that winning combination.
Totally.
Um,
And what's on the roadmap? Oh, go ahead.
Also, we need more TensorWave. That's what we need.
There we go. There we go.
Set
I'll
up
take
another
it.
node. That's all that.
We got you, man. We know a guy. I know a guy who can hook you up.
Yeah.
What's on the roadmap that you're currently most excited in? Like, how can others get involved in what you're doing, or people who need your help reach out to you?
Yeah. So for me, I think top of my mind is launching this kernel agent. So we're going to have a couple different ways. We're going to have a UI where you can input your PyTorch or input your Triton even, and you can select the target hardware and develop and iterate on kernels for that hardware. It's not perfect, but it works pretty well. Like we're pretty much like solved, compilable and functionally correct. And now it's a matter of getting them to be as efficient and fast as possible. So, users for that, people who want to try that out, I'd be, reach out. We'll get you set up, give you some credits, and and write your first kernel in 60 seconds.
Love it. I love it.
Thanks to you, kernel engineers.
I love it, man. Beyond CUDA, when you hear that, what does it mean to you?
It's really about the ecosystem and having like true choice and competition, which would inevitably breed more innovation, more, new algorithms, new research directions. To me, that's what it's all about. I give people, it's not like choice for the sake of choice. It's what happens when you have all these different options. You're not so much like all funneled down the same path, the same research direction. I think just having a healthy ecosystem breeds innovation. And so this is an inevitable thing that's going to happen. It's just somebody needs to come along and rally the ecosystem together, get everybody kind of thinking about what are the collective problems that we face and how do you resolve them.
That's it, man. You nailed it. That's exactly why we started Beyond CUDA and building this community to showcase all the things that are happening outside of the NVIDIA ecosystem and to continue to share ideas and things that can bring in true competition and true innovation to help support the AI needs at large. And it's what we currently have isn't going to be sustainable. And it's cool to see what you guys are working on at Mako. Is there anything else that you'd like to share that you're excited on or working on?
I want to know a little bit more about what you guys are up to.
Well, that'll be another episode. That'll be another episode. But we do have some exciting things coming down the pipeline. Big things. I'll just say that really big things that will be, if you're listening to this after May 14, go check the news. If you listened to it before, there's some exciting stuff that's happening and you'll be hearing more about it to continue to optimize compute and provide optionality at scale on the AMD side, but continuing to partner with others that are doing the
Oh,
same.
man. The bottom line is like nobody does it by themselves, right? There's like a foundational layer
That's right.
and NVIDIA, Intel, Trainium, TPU, like the bottom layer. The next layer up, the clouds, neo clouds like you guys. And then once you have that foundation, then the rest of the stack can start to really flourish.
That's right. And I think there's more and more people that are seeing that. Obviously, there was only one ecosystem to build in, and it was the NVIDIA ecosystem. I was talking with somebody else the other day, and they said that CUDA is not the moat. It's the ecosystem that was built in NVIDIA that is the moat. It's the people, it's the ecosystem that are together building and they understand what's there. It's a huge, saturated ecosystem, and it's cool to me to see more people that are looking outside and willing to build and grow beyond that. And so that's what we want to continue to build is an ecosystem. So if you're listening to this, find a new problem to solve and jump into the ecosystem at any layer of the stack. And yeah, it's exciting stuff, man. Dude, I appreciate the time that you spent. I appreciate what you guys are working on at Mako. Actually, one more thing. I forgot to even ask this at the beginning. I love the story of how you came up with your name, Mako. So the slogan, "Oh, better get Mako," comes to mind, but the actual story of how you came up with Mako. Tell the listeners where you came up with the name.
So, the Mako shark is known for being agile and fast. Like us, like our team, we're agile, we're fast. But importantly, the Mako shark is one of the known predators of the barracuda. And we like to think of ourselves as, hunting down those CUDA kernels, crossing that CUDA moat. Big part of what the mission is here.
I love it, man. Couldn't have said it better myself. I was tempted just to call this the Mako podcast, but you guys already had that. But love it, dude. Stoked for you guys. Much success. Where can people find you and Mako and learn more about you?
Yeah, mako-dev.com. So mako-dev.com. Find me on LinkedIn, Twitter, wherever. Check it out and let us know if you're writing kernels and need some help with it.
Sounds good.